The text imports several libraries for data analysis and visualization in Python. 1. Pandas as PD for data handling and manipulation. 2. Series and data frame from pandas for one-dimensional and two-dimensional data structures, respectively. 3. NumPy as NP for numerical operations, often used with pandas. 4. PyPlot from Matplotlib as PLT for MATLAB-like plotting. 5. Seaborn as SNS for better visualization, complementing pandas and Matplotlib. 6. It also sets up Matplotlib for use in Jupyter notebooks by allowing inline plots. This setup is crucial for data analysis and creating visualizations in Python. This code uses the Pandas data reader library to fetch financial data from Yahoo Finance. It imports the tools needed to grab the data and the datetime library to choose the time period for the data we want. Basically, the code sets up to gather and work with Yahoo Finance's financial data. This code is for analyzing data. It sets up a variable stocks that holds the stock symbol AAPL. It also creates end, which is today's date and time, and start, which is the date from 1 year ago. The code gets data for each stock between these dates. In the loop, it creates a new variable for each stock symbol and uses data reader to collect stock data from Yahoo Finance from the past year. The goal is to gather and keep track of this stock data for analysis. This code pulls Apple Inc.'s stock closing prices and generates a line chart showing how they've changed over time. Dates are on the horizontal axis and closing prices on the vertical axis. It uses up-to-date and reliable data, helping investors or anyone interested in Apple's stock performance to spot trends and make buying or selling decisions. This code uses addFuller from stats models and log from NumPy to check the relationship strength in the DF data frame, skipping any missing data. It saves the outcome in result and displays the ADF statistic and p-value, showing the relationship's importance. Pandas is imported as PD. This code loads essential libraries and prepares the settings for generating plots. It creates a 3x2 grid of graphs with original data on the left and its autocorrelation function ACF on the right, which shows how each data point is related to its past values. The first row is the original data and its ACF. The second is the data after subtracting each point from the one before it, first-order difference, and its ACF. And the third is the data after subtracting each point from the two prior points, second-order difference, and its ACF. This helps analyze how differencing affects the data and identifies any remaining autocorrelation. The plot is displayed at the end. This code generates a simple visualization to show partial autocorrelation in time series data that's been differenced once. It loads necessary tools, prepares two graphs, one for the data difference twice, labeled second-order differencing, and one for the partial autocorrelation plot with the y-axis from 0 to 5. The plot makes spotting significant autocorrelation patterns in the data easy. The initial lines of the script import the required tools for handling time series. Following this, the script defines the appearance of the output charts in terms of size and clarity. The script then generates a chart with two layers, using a common timeline. One layer presents changes in the data over 2 time steps for the first set of data. The other layer limits its vertical view from 0 to 1.2. The script also produces a graph showing how this change correlates over time, omitting any gaps in the data. To conclude, the script displays the combined chart, which visualizes the changes over time and their relationships for a specific set of data. This code loads an ARIMA model from the stats models library with the settings 1, 1, 2. It applies the model to the first column of a given data frame with the settings 1, 2, 1, fits the model to the data, and displays a summary. The summary shows key model details like coefficients and p-values to assess its accuracy. ARIMA is a popular choice for forecasting in time series data. This code creates a chart to show and compare the actual and predicted values from a model. It uses plot predict from model fit to get the predictions. Without updating for new data, dynamic equals false. Then plt.show displays the chart, helping the user see how well the model's predictions match the real values. This code generates two graphs to show a model's accuracy by plotting its residual errors. First, it collects the errors into a data frame named residuals. Next, it makes two charts using Matplotlib, one for the residuals over time and another for their density. It then displays these plots with titles, residuals, and density. By looking at these charts, you can evaluate how well the model predicts actual values. The code imports the ACF function from the tsa.stat-tools within the stats models package to compute the autocorrelation of a time series. It then defines train and test by thin columns and rows from the data frame df using .iloc. Specifically, train is the first column up to the 200th row, and test is the same column from the 201st row onward. The stats models module is also imported for performing statistical analysis and modeling. This code creates a simple ARIMA model 1-2-1 with the data we have for training. After setting up the model with the data, it shows a summary of the results. Next, the model predicts future values 53 steps ahead with a 95% certainty. The predictions are turned into a chart and shown with the training and test data. The chart also has a shaded part that shows the range of the 95% certainty. Lastly, the chart is presented for viewing. This code splits a data frame into training and test data to study COVID-19 effects. The training data includes information up to row 247, and the test data begins from row 248, both taken from the first column. This enables the analysis of COVID-19's impact using the data. This code creates a simple ARIMA model with settings 1, 2, 1 to predict future data for a dataset named train. It hides the model's training output using disp equals 1, but shows the summary, including coefficients and error terms. The model then predicts the next 5 points, calculating the forecast with a 95% confidence interval. These predictions are plotted alongside the actual data and marked with a shaded confidence range. The plot is made clear with a title and legend and is then displayed for analysis. Essentially, the code automates the process of predicting and evaluating time series data with a statistical model. This code creates a forecast accuracy function that takes forecast and actual data to measure forecast performance using various metrics like MAPE, ME, MAE, MPE, RMSE, correlation, min-max, and ACF1. It computes these metrics using methods like averaging and finding correlations. The function is then used with FC and test.values to get a dictionary of these metrics, helping to assess how well a forecast model predicts actual outcomes. This script uses pip, Python's tool for adding and managing libraries, to install PM-DARIMA. This library simplifies time series forecasting by choosing the best settings for the ARIMA model automatically. This code uses statsmodels.tsa.arima model for ARIMA and imports PM-DARIMA as PM. It auto-selects the best ARIMA settings for the data with pm.auto-arima. It starts by fitting the first column of the data and sets initial values and test types for the ARIMA model parts. The ADF test checks for the right differencing level. It also sets maximum values, seasonal parts, frequency, and initial differencing. It prints each step trace equals true, handles errors, and warns with options. The stepwise algorithm picks the model with the lowest AIC, which balances simplicity and fit. Finally, the summary of the model shows chosen settings, AIC, and extra details for easy review. This code predicts future values for the next 24 time slots using a trained forecasting model. It predicts 24 future values and their confidence intervals, makes a timeline for them, and then places them in separate series for the predictions, lower and upper confidence limits. These series are plotted along with the original data. The forecast is shown as a line graph with shaded areas representing the confidence intervals, all under the title Final Forecast of Apple Stock. The plot is then displayed.